Gold, the metal that has fascinated humanity for thousands of years. It shines with a beauty that never fades and holds a story that begins far beyond our planet. To find just 6 grams of gold, miners must extract and refine nearly a ton of rock. But how did this precious metal appear on Earth in the first place? The answer lies in the heart of dying stars. Billions of years ago, before Earth even existed, massive stars were collapsing in violent explosions. These explosions, known as supernovas, had released unimaginable energy into space. In those final moments, lighter elements fused together, forming heavy metals like gold, silver, and platinum. Tiny particles of these elements, scattered across the galaxy, mixed with cosmic dust and rock. Over time, this material gathered and formed our young planet, Earth. In its early days, Earth was a molten ocean of metal and fire. Heavy elements like iron and gold sank toward the core under gravity. Yet, a small portion of that gold remained trapped in the crust and mantle. Billions of years ago, metallic asteroids bombarded the planet, bringing even more gold to the surface. These collisions enriched Earth's outer layers, creating hidden veins of precious metal. As time passed, hot water moved through cracks deep in the rocks. When it cooled, it formed quartz veins, and inside them, gold began to concentrate. These simple looking rocks hid small but powerful treasures. Over millions of years, erosion broke the rocks apart, releasing gold into rivers and valleys. That's how early humans first discovered it, glittering in riverbeds beneath the sun. But how is gold found, extracted, and refined in the modern world? Let's travel deep into Earth to uncover the process. Gold is often found in veins of rock alongside quartz and pyrite. Geologists begin by studying maps, searching for regions where the crust once shifted or fractured. These places are perfect traps for hot mineral waters that carry gold. Satellites and aerial sensors help detect chemical and magnetic signs beneath the ground. Once a promising site is located, samples of soil and rock are collected for laboratory testing. If the results confirm gold, exploratory drilling begins to measure depth and quantity. Now, one of the most complex phases of mining begins: extraction. When gold lies close to the surface, miners use open pit mining. Massive excavators and trucks remove layers of rock to expose the ore beneath. The ground is carved into large horizontal steps called benches to keep machines safe and stable. In some places, these open pits stretch for kilometers, visible even from space. Where the rock is too hard, deep holes are drilled and filled with controlled explosives. The blasts break the rock into smaller pieces, ready for transport. Giant trucks then carry the ore to crushers, powerful machines that grind it down. But not all gold is near the surface. Sometimes it hides deep underground. In underground mining, tunnels and galleries follow the gold bearing veins. Concrete and steel reinforcements protect workers from collapse, while ventilation brings cool air below. Drilling equipment bores precise holes in the rock where explosives are carefully timed to detonate. Once the area is clear, loaders remove the blasted material for crushing and transport. The ore is then processed, ground into fine powder to release the gold inside. This powder mixes with water and chemicals, forming a thick pulp known as mineral slurry. In separation tanks, air bubbles or gravity methods help isolate gold from the rest. In some cases, cyanidation is used, dissolving gold into a solution for recovery. The gold is then smelted in furnaces exceeding 1000 degrees, melting into a pure, glowing liquid. It's poured into graphite molds, cooling into solid bars known as bullions. For perfection, gold undergoes electrolytic refining, reaching 99.99% purity. From cosmic dust to shining bars, gold completes a journey billions of years long. The metal born in dying stars becomes a symbol of beauty, power, and timeless value on Earth.